Hi, welcome back. This is going to be video lecture 2, I guess in week 8, and in this video we're going to be talking about rules of replacement. And we're talking right now in the we're talking about in the derivation system that we've been extending. This is turning out to be a little messy. Rules of replacement in SD+. So in regular SD, we didn't actually have any kind of rules of replacement. We just had the sort of very bare bone syntactic rules of negation elimination, disjunction introduction, for example. And in the last video, we talked about rules of inference. But now we're going to talk about the rules of replacement in SD+. Okay. So rather than actually writing all of these out, because there are a fair number of them, I'm just going to use the actual PDF to talk about a few of them and actually go over a couple examples of them and how we might actually prove them. And a lot of you, I think, have seen these already and had at least some intuitions about them. So here, let me actually zoom this properly. There we go. So here are all the rules of replacement, and most of them, you might be scared at first looking at all of these, but most of these we were actually already familiar with. So look at commutation, for example. We said before that, I think we actually proved this, that you have a sentence like P and Q, and this rule of replacement says, look, if you have the thing on the left, you can actually introduce the thing that's on the right, or vice versa. So if you have this sentence, a sentence of the form Q and P on the right, then you can introduce the one that's on the left. And we saw this in a simple case already with atomic sentences, right? So maybe if I just quickly go over an example. If we had a sentence like A and B, don't forget that this is just a shorthand way of writing and. If we had A and B, what we could just do is go conjunction elimination, right? So we just did conjunction elimination, and we just did conjunction elimination again on line 1. And then we could just reorder them how we like. We did B and A. And then we would just do conjunction introduction. And I'm being lazy here by not filling in numbers, but by now you guys should hopefully see what numbers I have to put in here. So this is just, this is how you would actually have to do the inferences in our system. But now we're going to say, we're going to introduce this rule of replacement so that we can do it much quicker. And one of the things you should keep in mind as well is P here needn't actually be an atomic sentence. It might be a complex sentence. So don't forget that all of these boldface instances of P and Q and R, these are all meta variables. So we can replace them with complex sentences. And that's an important thing to keep in mind. So the idea is whenever you have a sentence that has as its main connective this conjunction, then you can swap the order of the two conjuncts to turn the sentence into this form. And similarly, that holds for disjunction as well. So we've definitely gone over one of these. I know we've also gone over indipotence right here, where we can just get P by doing conjunction introduction, citing the same line twice in a row. And rather than doing that, we're just letting ourselves replace whatever sentence by conjoining it with itself to introduce a conjunction. And same thing with the disjunction here. The rule of association, I'm not sure if we actually did this one or not, but we can do it relatively quickly, right? So let's do it with the disjunction will be a little bit harder, but the conjunction will be relatively easy to prove. So if we have, for example, suppose we had A and B and C. Suppose that's our premise. Well, we can go by, so remember this is the main connective here, right? So what we need to do is we first need to break up A. We'll do that by conjunction elimination. Then we need to get the second conjunct out, so we'd have to go B and C. This would also be by conjunction elimination. Then we'd have to break these two apart, so we'd have to get B by conjunction elimination on line 3. Maybe I should number these. Stop being so lazy. So this is, again, line 1. And then we can also get C out from line 3, again by conjunction elimination on line 3. And now we need to build these things up in the right order. So our goal is to get A and B and C. Where here our main connective is this second conjunct here, whereas up here the main connective was the first one. So now what we need to do is build this up in the right order. So first we need to get together A and B. So we do A and B by conjunction introduction. And I have to cite 2 lines here, so I cite line 2, because that's where we have the A, and line 4, which is where we have the B. And then I can get to this last step by conjunction introduction, citing line 6, and then adding on C. So that's how you would have to, if we didn't have that rule of replacement, this is how you'd go from this conjunct being the main connective to this conjunct being the main connective. Sorry, this conjunction. This is the conjunction symbol, and this conjunction symbol being the main connective. Okay, and it's a little trickier actually to do the association with disjunction because you have to use lots of disjunction eliminations. And my suggestion actually is if you want some practice and you're not quite familiar or you don't feel very comfortable yet with disjunction elimination, which I think, I mean, given some of the performances on the quiz, there are some of you who could use that practice, is do the following. Assume this as your primary assumption and try to derive this sentence, where the only difference is where the parentheses are. And it's good practice to do that, not just to get better at disjunction elimination, but also to prove to yourself that this replacement rule is in fact a valid rule. So let's talk maybe a little bit about implication. Let's do a quick proof of implication here, just so we convince ourselves that it is in fact a valid rule. So implication says that when you have a conditional, you can replace it with the negation of the antecedent or the consequent. And I think if you recall, we did this in a truth table already. We proved that these are actually equivalent. Another way of actually how you can think of rules of replacement is that they're just saying that these two sentences, since they're equivalent, you can just plug in the equivalent sentence to this. So we know that this conditional is equivalent to the negation of the antecedent, just with the disjunction of the consequent. And since they're equivalent, you can just replace one with the other. So let's do that real quick. Suppose we have a sentence, if A then B. And we want to prove to ourselves that this is in fact equivalent to not A or B. That's what we'd like to get. And all we can do is actually help ourselves to this conditional. And this is going to be a little bit tricky. So I'm not actually sure what line I might need. I might need a little bit longer of a line. Let's bring this down. So one of the things you'll hopefully see is these replacement rules are really going to be able to shorten up a lot of proofs for us. So we have here disjunction as our main connective. And if we could get just not A, then we could just tag on B to the other end. Or if we got B, we could just tag on not A. But given that we only have this one premise, and when we think about this intuitively, it doesn't look like we're going to be able to just isolate not A to just do the tagging on process. So we're going to have to do some kind of subderivation. And the way we're going to do that is to do a negation elimination. So we're going to take the negation of this whole sentence. So we're going to go not A or B. And our goal is going to be to try to get some kind of contradiction. Now, I haven't really helped myself really by introducing this negation in front, because it means I can't get any access into what's in here. So that won't be of much help for me in terms of trying to make use of this auxiliary assumption. But what I can do is try to see if I can build something that's going to contradict with this sentence. So one of the ways I could do that is by doing something like the following. If I assume not A, then I can use disjunction introduction to get B. So I can make this assumption. Just make sure this is lined. So this was assumed for the purposes of negation elimination. And this we're assuming for the purposes of also negation elimination. Okay, so I have not A. If I have not A, I can always tag on B by doing disjunction introduction. And the only line I have to cite here is line 3. Because by the rule of disjunction introduction, if you have some sentence, you can always just tag on something else by using the disjunctive connective. And now notice that this sentence here contradicts with this auxiliary assumption up here, right? To make this really clear, let me pull it down and just reiterate it again. So I have not A or B. And this is a contradiction, right? I'm just reiterating this from line 2. I have the contradiction now, which means I can use negation elimination to just get A. So this is by negation elimination, citing lines 3 to 5. Now that I have A, I can use this first premise to go get B, right? Because I have the conditional and I have the antecedent to the conditional, so now I can pull out B. So this is by conditional elimination, citing line 1 and line 6. Okay, so now you might be thinking, alright, well, how's this going to help me, Bert? Because look, now I've got B, but I still don't have a contradiction anywhere. Well, notice, now that I have the letter B, I need to see if I can build a sentence that contradicts with either this sentence up here or with this auxiliary assumption here, or anything else really for that matter, but it has to be somewhere along in this scope line where I have to be able to get the contradiction. And you'll notice that, again, this is just a disjunction. So I can actually just add on to B. I can go not A or B, again, by just disjunction introduction. That is a valid rule of inference, right? I can take some sentence that I've already derived, and I can go within that scope line. I can just introduce anything else I want. So I can do disjunction introduction on B, so this is line 7, to get not A or B. But this just contradicts with our assumption up there. So we have, by reiteration, we can just do A or, not A or B. And this is by reiteration from line 2. That gets us our contradiction, which means since we assumed this for the purpose of negation elimination, we can take out the negation. And so we get this by negation elimination, citing line 2 to 9. So, I mean, here you start seeing that the rule of replacement is really handy, right? Because the rule of replacement for where were we? For implication lets us save a heck of a lot of steps, right? So we said, look, whenever you have the conditional, you can replace it with the negation of the antecedent and build it into a disjunction with the consequent as the other disjunct. So ordinarily we'd have to do this whole thing just to get here, but what this rule of replacement is letting us do is say, you know what, no, that's all right. Just go straight from this to this. And I encourage you to try to work out the reverse. So as an exercise, just to help yourself become familiar with these and just as some practice, is assume this. Assume not P or Q and see if you can get this conditional. Okay, so I think that's probably enough for this video lesson. We've covered here commutation, association, implication. Double negation, I'm hoping is already fairly intuitive for you, but I suggest that you work through it just to convince yourself that it is in fact a truth-preserving rule of inference. Or sorry, a replacement rule. And we've talked a little bit about idempotence as well. In the next video, I'm going to talk a little bit about De Morgan and some of these other rules of replacement here as well. And I won't be spending that much time on proving that all of these rules of replacement are valid. I encourage you to prove that for yourselves, because I'm going to want to move on to going over some of the examples from the next problem set. So see you in the next video.